Hi, my name is Natalie, and I will be talking about the iron cycle, um, its fluxes and reservoirs, its relation to the carbon, oxygen, and nitrogen cycles, and how humans have influenced this over the thousands of years that we've been on Earth and been able to mine it. Traditionally, we think of iron as only being in the lithosphere. But it can also be found in all of the spheres, including the biosphere, such as the iron that you can find in our blood. Iron naturally fluxes throughout all of the spheres on Earth. However, humans have influenced this substantially through the process of mining and the isolation of iron in industrial uses. So we can see this over here on this side of the diagram. I have the land, lithosphere here. So we can see that, humans mine iron ore and create these tailing piles, which essentially is a buildup of all of the debris and sediment that is a byproduct of the mining process. And these tailing piles can get miles in area. They are quite massive. Um, Within these tailing piles of all the sediment and debris, we can find barium, chromium, cadmium, cobalt, copper, more iron, manganese, lead, nickel, and zinc. So all of these heavy metals are in this sediment. So these heavy metals can get picked up by wind because it is just sediment. So the wind picks that up and it can enter into the atmosphere. Or what can happen is these heavy metals will be picked up by water that precipitates out of the atmosphere. So precipitation picks it up, bonds to the heavy metals, and it can go one of two ways. It can either run off of the land and just enter the water table that way, or it can intrude into these tailing piles and enter the water table. So essentially, the groundwater will carry all of these heavy metals and toxins into the water table and it'll take it eventually into the ocean. So regardless of which method it goes, runoff or seepage from intrusion, it will eventually go into the ocean. Another thing that can happen with the tailing piles is that slag can be formed, which essentially is just metal oxides and silicon dioxide. It's just a sedimentary rock that can form once these tailing piles get quite large. Eventually, it'll create this sedimentary rock. And through sedimentation, it'll go back into the lithosphere. Um, but yeah, so another thing that can happen in the mining process is iron ores when they are separated, when the iron is separated from the other substances in the ore, there are combustion reactions that occur that produce gaseous pollutants, such as carbon dioxide, carbon monoxide, sulfur dioxide, and nitrous oxide. So that will enter the atmosphere and be kicked up by wind and stay in the atmosphere for a while. Um, Another thing that can happen with all of these pollutants and the iron in the atmosphere, it'll be kicked around by the wind, and eventually it'll be deposited. So that deposition can occur back onto the land surface. It can occur on glaciers, on icebergs, or even just back into the ocean. It'll just be deposited, um, like I said, through wind. Um, all of this iron that is deposited onto the icebergs, onto the glaciers, um, eventually those will melt. And this melting basically allows the iron to go back into the ocean through that method. So iron enters the ocean that way. Another way that iron enters the ocean is through volcanic activity, such as these black smokers and mid-ocean ridges. So what happens here is that there is volcanic activity happening. So the melting of minerals like magnetite will produce iron, which is why that occurs at black smokers and mid-ocean ridges. So the melting of this material produces the iron, and the iron dissolves into the ocean, into the hydrosphere. So what happens to all of this iron and everything once it's dissolved into the ocean? Either it is processed by biota and goes through the biologic pump of the ocean and eventually ends up on the ocean floor, um, and is subducted, or the dissolved iron will react with oxygen, this O2 that's already in the ocean, and it'll become oxidized and precipitate as banded iron onto the bottom of the ocean. So this banded iron has carbonate within it as well as siderophiles. So all of these minerals that are produced in the banded iron will eventually be subducted and enter the lithosphere again and be sequestered along with carbon. So these iron deposits do have an influence on the sequestration of carbon into the lithosphere for long time periods on the geologic timescale, millions of years. So another thing that happens with human influence, so we're mining out all the iron and separating it from the ore. So once this iron is taken out and used for human purposes, like this little boat and as well, like a container ship, all these containers, once that is used for all of these man-made objects, that is essentially taken out of the equation, and the iron is, that iron specifically is no longer part of the natural cycle of lithosphere, atmosphere, hydrosphere, biosphere. That is taken out. So it takes away from the total amount of iron that is naturally cycling through the iron cycle. But humans also produce with these boats, with basically any transportation objects that require iron and steel, which steel still requires iron. We use these to move around, and that in and of itself produces more gaseous pollutants, such as nitrous oxide, carbon dioxide, and carbon monoxide. So that movement of all of these iron and steel objects produces more pollutants into the atmosphere that contribute to the carbon, the oxygen, and the nitrogen cycle. Thank you. That is my presentation.